Similar to the last problem, we've been asked about a ladder that's moving, but this time the question is asking for a much different thing. How fast is the angle between the ladder and the ground changing? That's this angle right here, theta. So that leads us to one of our three trigonometric equations. Usually there's one that's much better than the other, and this time that's again the case. If we take the derivative of each one, we'll have a d theta dt. It turns out that any of these three can work, but this one is the simplest because you've been given the rate that the ladder moves down the barn, 4 feet per second in the downward direction. So that means dy dt is essentially given to you. So that's why we want d theta dt and we're given dy dt. The next equation, you could have pulled this from the previous problem. If you did, this equation would be fine. The last one, you could have pulled this from the previous and this from the problem statement, but you'd still need the quotient rule, which makes the problem more time-consuming. For that reason, I've elected not to do either of those two routes. So now we'll go ahead and take the derivative of each term with respect to time. And on the left, we have cosine of theta, d theta dt, equals 1/10, because 1 over 10 is just a constant, times the derivative of y, which is dy dt. So now we can start plugging in everything we know. This was given as -4. Cosine theta was not given directly, but we have a right triangle. Here's theta, so cosine of theta will be adjacent over hypotenuse. Well, the hypotenuse is 10 because the ladder never changes. Adjacent is this value here, and we were told when the ladder is horizontally 8 feet from the barn. So that means at that instant, this is 8. So we're really looking at 8/10 d theta dt equals 1 over 10 times -4. We'll multiply by the reciprocal on the left, 10/8 on both sides, and d theta dt will equal 10 over 8 times 1 over 10 times -4. 10's cancel, 4 goes into 8 twice, -1/2, and we're asking for an angle change, so that would be radians per the time instance in this case was seconds.